Hi everyone. So today I would like to continue our programming training video, wrapping up numeric types for C#. So let's get to it. I'm going to open up Visual Studio Code. I'm going to go to Open Folder, create a new folder called Numeric Types. Types 4. Get in there, select the folder. Go to Run. Tab bar. Run new terminal. .NET new console. Okay, here we go. Gonna ask me for debugging, installing C# dependency. So this is our old console write line hello world. Let's delete that. So what I want to start off is float and double values have special instances. What I would like to start off is, well, we're going to enable debugging. Yes. By focusing on floats and double values. They have some special instances. So let's take a look. Special instances for double and for float. Do you have something called double? That none is, that means not a number. Value that is not a number. So this means value that is not a number, right? The same thing for float. Float has this value that is not a number. Why is this important? Because if you go to if you do something like this, console write line, you do 0 divided by 0, look what's gonna happen. You see? You get a none. There's a way to represent something like this. So let's do another thing, right? So we can say double none. Does that equal this? What do you think is going to happen, guys? So we're saying double none is it equal to that? You will say yes, it is. But C# says no. Because something that is not a number is not equal to something that is not a number. Because if it's not a number, it could be something else. So something else and something else are not equal. But what you can do is to check if this is true, you can just have one impression on one side. You can say double is none. And then let's do the same thing for the other side. Right? So we're saying, is it true that the first expression is not a number? And the second expression is not a number. So let's see what happens here. Let's run it with a 5. So you see, now you get a true. So that's how you get around it if you want to compare things. Beside is not a number. We have something called positive infinity. Which is positive infinity, which is it's written like so. So it's double positive infinity. Right. Then we have float also. Positive infinity. And you all say, okay, so I see that there's a pattern here. So let's see if I go int. You see, it doesn't exist. What about the decimal? Doesn't exist. So these guys only exist for double and float. So you have positive negativity. Obviously, there has to be a negative infinity. So infinity, and that will be double positive infinity. And then you have float positive infinity. Right? Then there is a special value of -0. Which is represented with double. You would do -0, 0. And with float, you would do is at 0, that's 0f. So how, so you're saying, okay, positive infinity, negative infinity. How do you get that, for example, right? So let's say if I go console, right line, if I divide 1 divided by 0, just want to put a label there so we will know what we're talking about. So let's see what this is gonna be. Just press F5 to run this. Oh, look! It's giving me the infinity symbol. All right. So now let's go the other way. Let's make 1 minus and 0 the way it is. Save it and let's run it. Oh, you see, you get negative infinity. And this goes the same way if this is reversed. So let's say 1 divided by negative 0. Let's see if I can run it without saving. Would this work? Yep. You get negative infinity. And then if I have negative divided by negative, let's see what's going to happen now. So you get a positive infinity. So that's something to keep in mind. Another thing I want to show you is that which goes along over here, right? So if you want to find out if something is not a number, then you would go double is none. So let's say 5.1 divided by 1/0, right? And then let's do divided by 0, right? So let's put some content here is none. Then I go 5.0 divided by 1/0, just to see, like, from the message itself that we can deduce what are we doing. It's the same thing over here. So this one we're gonna do divided by 0, yeah. So you see, is none 5 divided by 1.0, it's false. 0 divided by 0 is also false. So let's go 0. Okay, 0 divided by 0 is true. That's a non-number. But let's see what this thing of let's see if double positive negativity, if this is viewed as a non-number. Let's see what C# thinks of this. Yeah. So double positive infinity, it says this is a number, okay? So you can play around with this to find out if something is considered a number or not, right? So when you're dealing with double and you have calculations that you want to be accurate, because let's say you're dealing with finance, you're running into a problem because you lose the accuracy with double. So you, in situation like that, you need to use a decimal. So I mentioned that before, but now we're going to go to concrete examples. So double is mostly used for approximations, scientific calculations. Decimal is used for financial calculations. This is very important because if you're working on a program for banks and stuff, whereas precision is extremely important, if you will use a double versus a decimal, you're gonna run into issues. So let's demonstrate this, right? So let's say let's do a decimal. Let's call it 1/10, right? So 1/10 will be 0.1, all right? So they want me to use an M here, okay? Then then we have decimal 1. Right? So now let's do our calculation. Console, right line. So we're gonna do 1/10 minus, now we're gonna do, 1 minus 1/10 times 10. Right, so let's do this, right? We have 1 minus 1/10 times, okay, I misspelled right line here. So it's basically 1 minus 1/10 times 10, which is gonna give you a 1, and so that should be 0, right? So let's run this. Yeah. So we get a 0, right? So below this is decimal, right? Now let's do a double. So let's Let's duplicate this. So double 1/10. So we're gonna go like this. Then we're gonna go decimal, double again, double 1, just to show there will be a distinction here. 1.0. Okay. And now we're gonna write out the calculation, right? We expect a 0 back, right? So we are gonna have a double 1, double 1/10 times times 10. Over here, let me just put that will be consistent. So here is just gonna be times 10. Maybe double 1, double 1/10 times. Okay. So let it rip. Ooh, so this one gives us a 0. And this one gives us a 0. There's been some conversion done here. Somewhere. So that didn't exactly pan out. But let's keep going with float, right? So let's do float. Float 1/10. Float 1. 1f. So let's try float. Float 1. Float 1. 10f. Float 1 minus float 1/10. All right, so let's see what happened here. It also gives us a 0. There is some sort of a conversion going on. So let's see if I can spot it. Let's see if we can spot this. All right, so let's run this. Let's see what happens. So isn't that interesting, right? It gives us a 0 on all instances. Is it possible that the language changed? Let's go. Let's go at it with one more test. So what we're gonna do is we're just gonna compare them all. So I'm just gonna grab this. And I'm gonna set it equal to this. To the double. What doesn't it like it? Doesn't want me to compare them like that. Let me see if they will let me do equals. Let me put here the float. All right, let's see what happens here. You see? This is the test that works. Behind the scenes, they're not equal. But you're saying, well, does this work at all? So let's say 1 equals to 1. Just to test if this is fundamentally working. It's true. So you can see from this test that behind the scenes, these values are not equal. So there is some rounding discrepancy. Before I go any further, we know that this statement up here produced a false because is not the same. No, this statement was false because none is not the same as another none. But what you can do is that you can say equals. You can say, is this a none? And if something else is a none. So you're comparing that. So let's see here, just to show you. So you see, although the one above, double none equals none, it returns false, this one that I just mentioned returns true. So that's how you can check also if you're dealing with two nones. So going back to where we were, so you guys can see that floats and doubles behind the scenes are not really equal. Let's see if they're equal to each other, right? So double one and float, are they going to be equal? So the double is equal to itself. Now let's just do one more test. Let's test one with itself. So double to double. If that will be false, then all hope is lost. Yeah, so it's true. So itself is equal to itself. Decimal is equal to double is equal to float, but decimal is not equal to double and it's not equal to float. So let's dive a little bit deeper to show you what's happening behind the scene. So let's create a decimal value. Let's call it some decimal. And we set it equal to 1m divided by 6m. Right? And then we have a double, some double, and we will do 1.0 divided by 6.0, right? So let's write out those things. Some decimal and some double. Just put some context here so we know what we're doing. Notes are important because later when you're looking at this, you might get confused what you were doing exactly. I misspelled double here, okay. All right, moment of truth. So that it is. Look, guys. You can see that one, you have a lot more 6 and then there's a 7 at the end. And here, it just ends at a 6. So obviously, if we go like this, and we say equals, and then we do this, it's going to give us a false also. You see? This can get even more wider, so let's do some other things. So let's go like this. So we're gonna add some decimal 6 times, right? Right? And then we're gonna do the same thing for double. So we're gonna add double 6 times. All right. So wow, look at this. In the first instance, we are actually greater than 1. And the one below, we did not even get to 1. So you see, if you would use double for financial calculation, you would have lost fraction of a penny. Right? So now there's one more thing. Let's look at the equivalences, right? So if we go, we take this entire thing here. And we set it equal to 1m. Then we take the other one, some double, and we set this equal to less than 1. You're gonna see what happens. You see, the first one precisely tells you that this value is not a 1. Actually, you know what? Let's go like this. That will make more sense. So you see, in the first instance, we're greater than 1, and in the second instance, we're less than 1. So keep this in mind. When you're doing financial calculations, I cannot stress this enough, because it's very hard to figure this out after you write an extremely long program and then all of a sudden money is missing. So you might spend hours, days, weeks trying to discover what the problem is. So be careful whether you're using a double, decimal, or float. Remember, decimal only for financial calculation. No in, ands, or buts. So I hope this finale was very helpful. and let me know what you guys think. So we're completing our testing and running code against numeric types. We're going to be going after the Boolean next. So thank you so much for watching. All the best. Bye bye. Please subscribe.